So if I give you this box of pencils and you're behind the counter and somebody says to you, I don't need 12 pencils. I know I can get a whole box of them for $1.29, but A, I don't have $1.29, and B, I only need one. Okay? So the main operation for finding the unit rate, how much for one, is to divide. Okay? And that always brings up a good question. That's great. Okay? Divide. But division is an operation where the order matters, correct? Like if I were to multiply, I could do 12 times 129 or 129 times 12, and I would get the same answer, and it wouldn't matter which one I had to put in my calculator first, right? Okay? So, as I said, this is going to be a section where you get to use a calculator. Even though we just did all those operations with decimals, you should be able to figure the answer out, right? If you don't have a calculator. But since I've already assessed you on that, use the calculator and get the answer correct. So the two hardest things are going to be to figure out what to divide by what and what to punch in the calculator first, okay? Since I just told you it's going to be division, that's how you find unit rate. So I don't need 12. I just want one pencil. How much for that one little pencil? So here's what you're going to do. We're going to use a little bit of common sense. And that means that I'm going to ask myself, what am I trying to find? And the first thing I want to think about is what two things am I looking for? I'm looking for my variables. The number of pencils. If you have a highlighter, you can do it. If not, it's not a big deal. And the cost. All right? So those are the two things that I'm comparing. The cost and the number of pencils. Always find those two things because those are going to be your variables that we talk about. And then I want you to say this two ways. Am I trying to find the pencil per cost or the cost per pencil? Yes. I cannot explain this. Every year it's so weird that I have a hard time trying to explain how to figure out which one sounds right. But did one just sound right to you? I'm going to say it again. Are we finding, the pencil per cost, or are we finding the cost per pencil? Yes, it just sounds right, doesn't it? So this is going to be your number one helpful hint, because if I'm finding the cost per pencil, you know what per means, right? It means fraction bar. And you know what fraction bar means, right? Fraction bar means divide, right? Okay? So we are not going to use this symbol as division. You know how you did the house and you did your long division, you moved your decimals. We're not using that anymore. So to show division today, we're using a fraction bar. So every problem you set up today and every worksheet that I give you is going to have your unit rate as a fraction bar. So now that I know it's not pencil per cost, but it's really cost per pencil, this is something that I want you to watch me as I say it. Watch. Cost per pencil. In other words, cost is my numerator, per pencil. Literally, just like you read a page, right? Top to bottom, cost per pencil. So here's what I actually even want you to do so that you don't get confused, because I'll tell you, after teaching this for 15 years, what's the number one thing kids get confused? They don't know what to divide by what, they don't know what to punch in first, and they don't know what to put in the top of their numerator. So I actually want you to write the words cost per pencil, knowing that little fraction bar means the per, and that per means divide. Now I have it figured out, right? Cost goes on top, pencil goes on bottom. So the cost, fill that in. The cost is $1.29. Whoops, decimal in the wrong spot. So the cost is $1.29. And the number of pencils you get for that cost is 12. So part one, kind of the hard part is done. Part two is, okay, now that I have that written, how do I get my answer? Okay, so what did we say? It goes with the flow, top to bottom. So when I go to punch this in my calculator to figure out how much it costs for one pencil, which number should I punch in first? The one I said first, and the one I wrote first is the one I punch in first. Okay? So before we do that, though, I want you to turn your calculators on. This is why I'm recommending that you use your classroom calculator and not your phone calculator, because we want to have the calculator do all the work for us. We're dealing with money, right? Because we're dealing with money, I want to go out 2 decimal places. I want to go out to the hundredths place, right? So this calculator is so smart. The person who made it programmed it for you. So do you remember at the beginning of the year we talked about this word mode? I want you to hit the word mode. Then I want you to look at the word float. Use your little toggle arrows here to go down. And then right now, none of those numbers are highlighted, which means it's going to go out to as many places as on mine. Yours might be. It goes out 5, 6, 7. It can go out 9 places. If yours is dead, just grab another one. So because I'm talking about money, I want to highlight the number 2. If it's dead, leave it out, and I'll replace the batteries so that next hour. So just bring it up to my desk. And then I'm going to hit enter. And then I'm going to hit clear right here below this. And so now, whatever problem I type in, it's going to round it for me. Okay? So I've already got it out to money. 2 is a pretty standard setting to keep, right? I don't usually, unless it says specifically round to the nearest tenth or whole number or thousandth, just keep it on 2. It's a safe bet. Okay, so now I type in 1.29, and how do I get that fraction bar? Well, somebody said, how do I get the fraction bar? It means divide. So I push the division button, which is right there, right? So that's the division button. 3rd time's the charm, huh? And there, it even looks like a fraction bar. It doesn't even look like that little symbol, right? So I want to take that 129 divided by 12. I'm going to hit enter. Enter is the same as equal, as you know. And look at that. It already rounds it for me. So what does that mean in terms of my problem? That if I don't want a whole box of pencils and I just want 1, then I only owe them what? 11 cents. Okay, the most important part is coming right here, though. It's how am I going to write this as my answer? Do I just write a plain old 0.11? No. So there's a very specific way that I want you to write it, okay? So we're going to write the answer as a unit rate. So I want you to put write answer as a unit rate. And what that means is write it as a fraction. And if a unit rate means how much for 1, then my denominator is going to always be a 1. It's going to always be a 1. So I'm even going to get a marker and just kind of darken that in, because your answer will have a 1 there. Okay? And then I'm always going to ask you, write your answer as a unit rate, and then you're also going to see, don't forget your unit. Don't forget your unit of measurement. What am I measuring? Am I measuring distance? Am I measuring time? Am I measuring money? Okay, so by that, that's where this thing comes in handy. It's going to cost 0.11, and you could use cents. Sometimes people use $. 11 cents for 1 what? Pencil. That looks like a weird way to write your answer. It seems like a bit of an overkill, like that's a bit much. Is that really necessary? Yes. So I had cost per pencil. I need the cost and the number of the pencil in my answer. That is one complete problem. If it costs, now watch this. Follow me and listen. If it costs $1.29 for 12 pencils, then it costs 11 cents for 1 pencil. Okay? Now, normally, that's not how it works, right? Like in the real world, you know how you get a better deal usually when you buy them as a pack? Probably what would happen is the person at the store will not just bring 1 pencil out and give it to you for 11 cents. because they want you to get a better deal, right? So they'll say it costs $1.29 for 12 pencils or a quarter for one. Usually that's how it goes, isn't it? So you're like, man, it's 11 cents a pencil, and I can get, you know what I mean? But I have to pay a quarter for one when it really don't. Yep, that's how the function, it works in the grocery store and all those things. Because you do get a better deal when you buy more, usually. Correct? Okay. So let's do another example. That was kind of our first one to get us started. Let's say that you can get, let's say that was a cost one. Let's do one that doesn't always have to be money. You can go, let's compare. Who went faster? Okay? This is person A. This is person B. Person A ran. I'm making this up, so I'm hoping that it makes somewhat sense. Person A ran 3.5 miles in, let's see, we're going to do minutes. So, 18 minutes. Okay, pretty good, pretty fast. Person B ran 2.1 miles in 14 minutes. Okay? Yeah, I know person A ran more time and more distance, obviously. Person B ran less time and less distance, but who ran faster? Okay? So I'm comparing. And we're going to do some comparing next where I'm going to say, what's the better deal? So, for example, if you had to go to the store and you could buy a 32-ounce jar of ketchup for $3.29 or a 24-ounce for $2.59, yeah, I know that's cheaper. The better deal does not mean which is cheaper. It means what are you getting more for your money, for the unit rate. And the only way you can compare is to find the unit rate. So, I want you to ask yourself two questions. What am I figuring out? Well, first of all, what are the two variables I'm talking about? Miles per what? Miles and minute. I cannot stress enough how important that is that you find those two words. Because once I find those two words, I ask myself, do I want to know the number of miles per minute or the number of minutes per mile? Miles per minute? Yes, miles per minute. Because how many can I go in 1 minute? Not how many minutes does it take me to go 1 mile. How many miles per minute? All right? So, what do I do now that I've determined the correct wording? What was that process? Write it as a fraction. Miles per minute. Let me give you a huge hint. Hint is going to be, if you ever get confused, time, your unit of time. Whether you're seconds, minutes, hours, days, years, months, your time is going to almost always be in your denominator. Time in the denominator. Okay? So now we fill in what we know. What do we know? We know that person A ran 3.5 miles. And you know what you could do? You could include that word there just so you don't know that you don't forget it. In 18 minutes. So let's figure out their unit rate. Then let's figure out person B's unit rate. They did 2.1 miles in or per 14 minutes. And literally, once I have it written as a fraction, I am literally home free. Like, I just have to do some division. So I want you to use your calculator right now to give me an answer in a minute or two about who runs faster. Not farther, not time. Who had a faster speed? And I want you to write your answer as a unit rate. As soon as you hear me say answer as a unit rate, you know that your denominator is going to be 1. And it's going to be miles per minute. Okay. Who ran faster? Okay, so did you type in 3.5 divided by 18? This person is running 19 hundredths of a mile, which is about almost 20% of the mile, right? In a minute. Okay? That's their speed. 19 hundredths of a mile. If you took a mile and separated it into 100 equal parts, then they could do 19 of them in a minute. All right? Or, I guess you could leave that one, 3.5 divided by 18. Or this person did only 2.1 in 14. This is a different calculator than you have. This is an upgraded version of it. So yours probably is a little more old school. Okay, so is that what you guys came up with? Yeah. Everybody has that answer? So this is kind of a two-part question. Oh yeah, I wrote 14. Who ran faster? Well, faster in this case does mean the bigger number because they covered more distance in the same amount of time, right? They each ran for a minute. This person ran 19 hundredths of a mile. This person ran 15 hundredths of a mile. Oh, they must have been running faster then. So person A ran faster. Okay, does that make sense? Okay. Then one more thing that we're going to talk about is if I were to give you a table, okay? Meaning I give you a table of values. So let's look at this. Go ahead and make kind of a little table on your... So we know how to find a unit rate. We know how to find two unit rates and compare them. Let's say that this is time and this is distance. Okay? Well, I want you to understand something really quick. Time and distance are kind of vague. Do you know what vague means? It means not very specific. It's a general. Time. Hey, there's a lot of ways to measure time. What are you talking about, Mrs. Z? Minutes, seconds, hours, days, weeks, decades, centuries. Distance. You talking about an inch? Are you talking about a mile? A meter, a yard. So when that's given to you, or when it's not given to you, you could just say units per whatever. So let's just say the distance is going to be in hours. Or I'm sorry, the time is going to be in hours, and the distance is going to be in miles. Okay? And then I'm going to say 3 hours went by, and whatever this vehicle is, you could say it's a person on a bike. They traveled this far. In 6 hours, they traveled this far. 9 hours was this far. And 12 was 54. Okay. We're going to leave that last one blank for a minute. So, my question to you when I give you a table is going to be, how fast is this person on a bike going? How fast is this person? We can say it's a bike, whatever. I'm not sure. I'm sure it'll work out. Riding. Okay? Here's the thing. The name of the unit is called finding the unit rate. It means how much for one. I'm not going to come out and ask you every time, find the unit rate, find the unit rate, find the unit rate, even though that's what you're going to do for every single problem I give you. How fast is this person riding means how many miles an hour are they going? Miles per hour. I want you to write that. Miles per hour. Think about in a car. I know none of you have your license yet, but I want you to think about what that means. It means how many miles do you go in 1 hour? This sounds like a trick question. I'd be amazed at how many kids can answer it. Miles per hour. How far can you go in 1 hour if you're driving 60 miles an hour? 60 miles, right? Think about it. That means every minute, there's 60 minutes in an hour. Every minute you go a mile a minute, a mile a minute. If your cruise control is set on 60 miles an hour, right? What if you go faster than a mile or than 60 miles an hour? What if you go 70 miles an hour? How far will you go in an hour? More than 60 miles or less? More, because you're going faster. So think about what 60 miles an hour means. I know you think it's a speed, but speed is basically your distance divided by your time. So this one's a little trickier because I know what you're thinking. Oh, how awesome. It's already set up for me with the 3 and here in the 13.5. But what do I really have to do to divide? These numbers are the miles. These are the hours. Don't think that that's already set up for you as a fraction because it's not. It's actually upside down. Because these numbers are the miles. 13.5 is the miles. The hour is 3. So you're going to take your calculator and you're going to say 13.5 divided by 3. Oh, 4.5 miles an hour. Okay, that's a reasonable pace. I think I read somewhere that the world's fastest man, let's get speed. I know 25 miles an hour is the speed that you're supposed to drive down a residential street, right? Some people do not do that. They go way over it. But 25 miles an hour is not super fast, right? I read the fastest person in the world is 22 miles an hour. Can run. Yeah, I don't know what his speed is, but Usain Bolt probably is. But this was years ago. I haven't re-looked it up. So that might be something that's interesting tonight. Maybe look up how many miles an hour is the fastest man, okay? So this person's riding a bike at a nice, easy stroll, right? 4.5 miles an hour. It's not record-breaking speeds, is it? Okay? So then here's my question. What are all these other numbers there for? If they can do if it takes them 3 hours to do this many miles, then for this many miles, which is double that amount, then it must take double that amount. Hey, let's just check to make sure that's true. Let's do 27 divided by 6. Oh, that's also 4.5. Check to make sure those two are also 4.5. Good. Okay, so because all of those, that means that this person, and I think it would be kind of hard to do, is riding their bike for 12 hours straight at a constant rate of speed. They never go faster and they never go slower than 4.5 miles an hour. That's kind of hard to do. That's okay though. So all I asked you is how fast is this person riding? You divide, but you got to do the upside down. So look how I'm going to write it. They're going 4.5 miles in 1 hour. That's not bad, right? That's maybe a trip around the city of Riverview. From the forest to the reflection pond, maybe up through Seeds, back to the forest, an hour. You can do that in an hour, right? Okay? So here's my question. Actually, you know what? We'll talk about this later. We could figure out what to do here. What if I asked you, this is kind of a little preview. So if they can drive 4.5 miles in every hour, how far would they go in 13 hours? This is kind of like an extension of your thing. I haven't taught you this yet, but you can use the information we just found out. As long as they don't change their speed and everything stays the same, they're pedaling like a robot. They have cruise control on their bike. How far are they going to go in 13 hours? I just want one person to get it. Every mile they go, or every hour they go, another 4.5 miles, Jared. Say that again. Yeah. Yes, they would go another 4.5. So another 4.5 up means another 1 hour went by and another that. Okay, does everybody understand unit rate? So there's 3 kinds of problems you're going to be given. Just find the unit rate, right? How much for this? Then you're going to be asked to compare. And it might be who went faster. What's the better deal? What's the better buy? Meaning, I know this costs more, but it might cost less per battery if you go with the bigger. And you're going to be given a table. All right? Think you can do this? Okay. So let's do unit rate.